Hi everyone, this is Babaiah, Assistant Professor of ECE Department from MLR Hyderabad. Previously, we have discussed about all the mathematical expressions and what are the transfer function model and state space model. For the today's session is now we are going to learn transfer function model, the best example for the block diagram reductions. Here we are going to use the block diagram, what are the basic blocks are available, what is the block diagram, basic block diagram, what are the elements are available, what is the transfer function of the block diagram. Now we are going to learn all this for the today session. Just coming to the overview of today's session, just block diagram. Now we are going to discuss on the block diagram and what are the basic elements of the block diagram and what is meant by block, what is meant by summing point and what is meant by take-off point and branch point. All these are now we are going to learn for the today session. Just coming to the first block diagram. The block diagram consists as single block or else more number of blocks together is combined to the one single block, combining to the block that are used to in the representing as a control system as pictorial form or else picture or else photo. We call it as photo or else picture or else pictorial form. All these are the same words, but here in every block diagram it is consist as single block or else more number of blocks that are combined to used to representing in the control system as a pictorial form. That is known as a block diagram, right? Coming to the basic blocks of the block diagram, here just see, observe, these are the basic elements in a block diagram. The block diagram definition is here just consists the single block or else the more number of blocks combined into the blocks. This is the used in control system representing with the pictorial form. This is nothing but the block diagram, pictorial or else picture also, picture or photo, all these are the same words. Photo, this is the representation in the control system by using the blocks. The basic block diagram is consist as a, this is the basic block diagram with unity negative feedback, with h of s is the feedback gain and here the negative is the negative feedback, end with the negative sign, so it is the negative feedback. This is our input signal and output signal C of S. We have a three basic elements. What are that? First one is the summing point and take-off point and the third one is the blocks. These are the blocks, H of S and G of S. These two are the blocks and this one representing with the summing point and this top is, this one is point is nothing but the take-off point or else branch point. Just here, what are the basic elements? One is the block, G of S and H of S. These two are the blocks are consisting in the one block diagram. This is block is the first point and second one is the, just here observe, take-off point or else branch point. This point is the take-off point or else branch point. I am going to write here second is branch point or take-off point. Take-off point, both are same. And third one is here, just here observe, this is the summing point. This is the symbol of the summing point. The third one is the summing point, right? These three are the main basic elements are available in the any block diagram. Next, coming to the one by one, we are going to learn what is the take-off point when we are going to use and block the summing point. All these are now we are going to learn. Just coming to the block, here just observe the transfer function of any component or else any block. The transfer function of any component is representing by the block, right? Transfer function can be representing with a block and block has a single input and single output. Here just observe, this is the our block, this is X of S is the input signal and Y of S is the output signal. So the what is the transfer function here? Transfer function is the Laplace of the output to the Laplace of input, the ratio of Laplace of output to the Laplace of input. This is the transfer function. This transfer function we are going to representing in the block. in the block g of s. This is nothing but the g of s, or else g of s equals to x of s by y of s. This is equals to g of s, or transfer function is y of s by x of s. We are representing in the block only, right? Every block has single input and single output. This is the single input and single output. Every block consists of single input and as well as single output. Just here, this is the block diagram having the input x of s, y of s. The transfer function is g of s equals to x of y of s by x of s, right? From this, we want to calculate the output of the block. For example, from this, now we are going to calculate the output. Output is here y of s, right? Y of s equals, from this equation, just observe, output y of s equals to x of s into g of s, or loop gain, or transfer function g of s into our gain, g of s or gain into multiplied with the x of s, multiplied with x of s. This is the output of the block. Output of the block is transfer function is multiplied with the input of the block, right? This is the output of the block. Next, coming to the take up a summing point here, just observe summing point. We are representing with the summing point just like this one, and every summing point has more than one inputs. Just here observe, summing point is represented with a circle. This is a circle, right? Representing with a circle. In this circle, we are going to mention a cross mark. Just this is the cross mark mentioned inside it. So it has two or more inputs. Here just observe A and B. These two are the inputs for the following diagram. Just we observe, this is the A is the input and B is the output. For every summing point has two or more inputs and but single output. For block only input, single input, single output. Here summing point more than two are the inputs and output is single. Right? Here just, and for all these we need to calculate the by using addition operation and subtraction operation, both addition and subtraction. Now we are going to see what are the here. Just this one is the summation operation or summing operation, or else addition operation also we call it. Just here observe, summation operation, A is our input and B is our input, but here mention the positive sign. These two are signals are adding in the summing point. So here output y equals to A plus B. This is the output of the summing point. Single output, two are the inputs A and B. This is the addition operation or summation operation, right? Here just observe one more from this diagram. We are going to calculate the output of the summing point. Just adding, just we get the this one. Finally, we get the A plus B. Y is the summation of A and B. Just here observe. The following figure shows the summing point. This one is the summing point. Two inputs A and B, and one is the output Y. So Y equals to A plus B. That is our output, right? This is the summation operation. Next, coming to the just subtraction operation. Just here observe, A also here input and B also input, but here A is end with the positive sign, but here B is end with the negative sign. These two are just subtracted means output Y equals to A minus B. Output Y equals to A minus B, right? This is the subtraction operation, or else difference also we call it as difference or subtraction, right? Here finally we got Y equals to, from this just here observe, A is the positive, A plus, B is minus 1, minus of B. Finally we got the value is A minus B, right? Differences between the input signal A and input signal B. This is the difference. This is also difference of between the two signals, or else the subtraction operation we call it. Next, combination of both addition and subtraction. Just here observe, from this circuit or this summing point we are observe, one is the input signal A and B also input signal. Here adding A plus B, adding addition operation, and that one third signal is C. that is the end with the negative sign. So output y equals to addition operation as well as subtraction operation. Addition operation and subtraction operation, right? Both these two in this, from this diagram we are going to observe the both addition and subtraction operations are occurred by using this diagram, right? Here finally we got the output, this one only, right? This is about the summing point. Next, coming to the take up point or branch point. Just here observe, take up point or branch point. For every take up point, by using the take up point or else any branch point, we need to take the same signal or apply the same signal to more number of blocks or else more number of summing points. We are going to use the take up point. Here just observe, this point is the take up point. By using this take up point, we are going to give the same input signal. Here same input signal is what? R of S, right? Same input signal applied to the more number of blocks. By using the take up point, we are going to give the same input signal to the more number of summing points or else blocks. Here we are using the blocks here. GA first block, the same signal is applied, and same signal is again applied to the second block, and the same signal is applied to the third block, right? We got the output, respected output for the each block, respected output for the each block. This is the use of the take up point. By using the take up point, we are going to give the same input to the more number of blocks or else more number of summing points. Just here observe, take up point is a point, right, from which the same input signal, just here observe, the same input signal can be passed through more than one branch. This is the one branch, second branch, third branch, like that. More than number of branches means here give the signal to the summing point block. This one, that means the help of take up point, we can apply the same input to one or more blocks. Here are summing points, right? This is the figure or else this is the representation of the take up point. By using this take up point, we are going to give the same input signal applied to the more number of blocks or else more number of summing points. This is about the this is about the take up point use in the block diagram. And also next, coming to here, just representation. Coming to the representation of the negative feedback, I consider the negative unity feedback. Here just observe, from the output signal, we give the output signal as again given to the input side. Just arrow mark, just observe, this is nothing but there is a no feedback. So that's why it is nothing but the feedback gain equals to 1, or else we call it as unity feedback, negative unity feedback system. This is nothing but the take up point. So C of S signal, same signal apply to the input, here, right? Same input signal by using the take up point. The use of this take up point to, we connect the C of S signal again to the input side, right? This is the unity feedback system. This is about the what is meant by block diagram, and consists as a block, summing point and take up point. Just observe previous all. Here block diagram, we know block diagram, every block diagram consists as a some elements, basic elements, right? Basic elements are the block, summing point and take up point, right? We are observe all this from this block diagram, right? Here now block diagram is having, or else block has single input and single output, we learn. This is next, summing point has the more than 2 inputs, single output, right? As well as third one is the take up point or branch point. By using this one, we are going to give the same signal to the more number of blocks and more number of summing points. This is about the block diagram representation, and it has some basic elements. We learn all these from the today session, right? Thank you all.